Hi everyone, this is Asim here. Welcome back to the channel. So in this fifth episode of Be the Hacker series, we are gonna talk about an uber class of bug, that is remote code execution. So we would see how some of the high profile companies like Google, Facebook, PayPal and GitHub, these were affected due to this bug and how these were exploited. So apart from Google, in all of these, the bug is quite simple to understand. In Google's case, it's a lot more complex because Google App Engine is involved. In this video, apart from the Hackthissite mission, I have also included a small vulnerable application that I wrote in Python. It uses the Flask web application framework. So it's a web application similar to what you would see in the Hackthissite mission. I have included the links in the description and of the GitHub repo. You could clone it. I have also shown how you could set up that and play with it. You could tinker the code and do as you like with that. So, and if you have not pressed the bell icon after you have subscribed to the channel, do that, because unless you do that, you might miss some of the videos. Like you might have missed the basic cryptography video. If you haven't checked that out, please do check that out. It's the previous video to this one. So that's all the intro that I had. Now let's start with the missions. So I've already logged into the system. Now let's check the mission. So basic mission 7. The password is hidden in an unknown file and Sam has set up a script to display a calendar. Requirements: basic Unix command knowledge. So let's check how we display a calendar in Unix. As far as I know, cal command is there. To show a calendar in the terminal, simply run the cal command. So if I do a cal command, so I get a calendar. Let's check the man page for this. So it shows that displays a calendar to the date of Easter. So it looks fine. Let's go back to the mission. This time network security Sam has saved the unencrypted level 7 password in an obscurely named file saved in this very directory. So it's no more password.php as it was in the second mission. In another unrelated news, Sam has set up a script that returns the output from the Unix cal command. So that was that. Here is the script. So if I just do a blank view, I get this. So it's similar to what we saw here, right? So let's check. So probably this, if I do, so it shows the calendar of 2020. So probably this cal.pl is doing like running this cal command in the backend. Yeah, it looks the same. So pl is for Perl. Let's check the source, inspect it. So yeah, it's sending the post method. It's doing the cal.pl. So let's sit back and think what's going on here. So probably this is the argument to the cal command, and if we leave this blank, it displays as it's being displayed here. So if I want to like list the files in the current directory, so what I do is ls command, and if I want to concatenate both of these, so what I would do is cal 2020 call ls. So first the calendar would get printed and then the files in the directory would get printed. So probably I could do something similar here as well. So if I do this and then do this, so this is the calendar printed. Let's check the bottom. So here it shows all these. So you could see there is a dot and a two dots. So dot stands for the current directory and double dot stands for the previous directory. And this is coming because it's probably doing this ls-a. So as you can see here, ls-a shows the dot as well as the double dot. So basically -a is for showing the hidden files. So if we see, so do not ignore entries starting with dot. So entries starting with dot are hidden files. So suppose, so doing a normal ls won't list this. Even these won't be displayed in the file manager as well. Like if I do this, so you won't see these here. I had to enable the show hidden files. So I had to enable this to show the hidden files here, like the gitignore file. So that's that. So we found that this is the obscure file which would be saving our password, I guess. So we got the password. Let's check this first. So it's congratulations. So before we move on, let's do one more thing. Let's try some other commands here as well. We had to be in level 7. So 2020 cat cal.pl. So cal.pl is the file. So we could print the code of the of this code itself. So I don't know Perl, but what I could do an intelligent guess on this, that there is 3 functions: cal, ls, and a cat function. So these are responsible for the functions that you could execute there. So if I try to execute something funny, like if I do cat etc password, so I think I won't be able to do that. So that's that. So I also made a Python code so that you could play with it. So what it does is it tries to replicate the same functionality in a bit different way. So this is the repo. So in this folder there's the code. So you could download this repo and you could go into this folder. So here are the instructions how to set up the file. So it's a simple Flask application. It's not a lot of things. So if I do cat main.py, so it's only these main lines, like 10-12 lines. So what it does is it runs a Flask server, and then if you don't give an argument, it would display the output of cal command. However, if you do you give a cmd argument in the URL, so it would run that command. So basically it's a vulnerable web application with remote code execution. So the process to set up is you need to set up a virtual environment. It's an optional step, but I recommend it doing so that you don't mess up with other Python libraries on your system. So I have set up with 3.8, Python 3.8. You could do with any Python 2 as well. So we need to activate the virtual environment. So you could see that here it wasn't activated. Now it's activated. So Python -r, sorry, it's not Python -r, it's pip install -r. So if I do this, so basically I'm trying to install all the libraries that are there. So these are the libraries, and then I need to run export flask equal to app.py, and then I to run flask run. So what this would do is it would run a development server. I could open it here. So it's running the output of the cal command. So if I do here give a command like cmd equal to ls, so it would give the output of the current directory. It's not limited, it doesn't have only those 3 commands, it could give all these. So it could run any command, like suppose if you want to run date command, you could get that as well. So since the code is written in that way that you could play with it and do similar stuff, so these are all the instructions that you would need. So that's pretty much about it. I think let's move on to the session on reports. So let's start with the first report of today. It's from a researcher Alfie. Sorry if I pronounced that wrong. So here he used Shodan to find open Dreambox 2.0. So he used a remote code execution bug in that. So what he did was he entered a Shodan doc where he could find all the Dreambox, which returned a 200 status, which is a correct status from the server. So there in the admin panel, so he got a endpoint, web admin script endpoint. So there was a parameter command where you could insert any Linux command, as we saw in the Hackthissite mission and the Python server that I put up. So here if you entered ID, you would get the ID of the currently running server user. And if you used a cat command to etc the password file, so the password file would come out on the screen. So that's all about this. So let's come to the second bug and the highest bounty fetched in all of these reports. So it's a $36,000 Google App Engine RC. The funny thing about this report is even the researcher didn't know that it was a RC until Google confirmed, as we would come to know later. So it's quite funny, like if you found a bug and you didn't know that it was a highly critical bug. So we would see how the severity was, and he was told not to mess with the internal APIs so that like it could break something very easily. And a lot of employees were CC'd into the report. So let's come to this. So in short, he got access to some non-production Google App Engine deployment. It's highly technical and very specific to Google App Engine. So it's very hard to explain all these without knowing actually what Google App Engine is. So I would try to cut off all those like very specific things and focus on the concepts that were being used. So, he mentions that Google App Engine performs some internal actions, and these are usually done using protobuf. By sending protobuf messages, protobuf is a binary wire format, and it was done to an HTTP internal endpoint. So he further mentions how the PB message, the protobuf message was. So it had service name, method, request ID, and a lot of other things. So since he found that the endpoint has access to some internal stuff, so he was sure that it was something related to appengine.google.com. But he couldn't figure out a lot about that from the HTTP endpoint. So what he did was he uploaded a statically linked nmap to GA. GA is the Google App Engine. And ran it against the server so as to find the open ports. And eventually he found that there was only a single port, that was port 4 open. So another thing to mention, he uploaded a statically linked binary because if it would have been a dynamically linked binary, the other libraries that it was linked to it, those should have been there on the Google App Engine, which you cannot be sure of, and that's why he uploaded a statically linked binary. Another thing was that since the server was only read only, he uploaded it to a temp folder where he could give them the execute permission. So later on he found that there was option for JSON encoding as well, and it was way easier than PB messages because those were in binary format. Since he couldn't find any other endpoints on that, so first what he did was he tried to collect all the protobuf definitions from wherever he could, all the class files and jar files, and he decoded them to figure out anything that could point to some hidden API or features. So he found something interesting in this file appmaster.proto. It had some PV message that could modify like internal methods for modifying the internal settings of App Engine. And there was an API called AppMaster with some methods defined in it. So eventually figured out that there was a main binary Java runtime launcher EX which contained a lot of command line parameters. So he tried to figure out the parameters that was being passed. So he wrote a simple code and he executed that, and he found that these were the parameters. So he noticed that these were the APIs, and the parameters were actually the APIs, and he had used a log service one. So he focused on this stubby API because it was not very similar and obvious from the other ones. And then he came to know that there was only one post regarding that, and that was a 2010 post. So you could see the persistence of the hacker, that he tried to figure out and go in depth when there was not documentation and there was no like surety as to what you would figure out and all. So he found one post that said that API called stubby.send took too long to respond. So it immediately triggered in him that there was a call called send in the stubby endpoint. So he tried that, but he couldn't be sure that it was working because the error was very generic. So he first tried to figure out the exact error from a fake one. So even if the endpoint didn't exist, it would throw out a similar error as non-existent API endpoints. So he first figured that out and he rooted out the fake ones and the real ones from that. So later on he uploaded his gRPC client and he discovered that on non-production servers he had access to stubby.send, whereas on production servers it was not working. I think it could have been deprecated or something, but he could do that. So he did this all. He did some more of his research. He collected the JSON PB messages and all those things, and then he sent a report to Google. So it was immediately assigned a P1 priority. So after the initial report was submitted, he tried to look at whatever he found, and then he found that there was something interesting apart from stubby, and that was a app config service. He also looked in other PB definitions, and there were some interesting methods for there. That was app config service.config app and set admin configuration. methods. So these allowed him to set internal settings such as the allowed email senders, the app service account ID, ignoring the quota restrictions, and setting his app to a super app. So super app in itself sounds super cool and like uber cool. It could have some privileged access that other apps didn't have. So he submitted all these findings to his already submitted report. So he added there. So he was given the reply from the Google. You could see that it was something critical. So they said that please stop exploring this further as it seems that it could easily break something. So these APIs were like very critical, and if done in a wrong way it could break something very critical. So he was warned about that and he was asked to stop his further explorations. A lot of employees were CC'd into it, Google employees, because I think it was too critical, and so a lot of person were CC'd into that. So later on it was fixed and he got I think the highest bounty that was rewarded ever, and that was 36,337. So even till then he didn't know that it was an RC. So he asked one of the Googlers in the reward panel and told that it was RC for the way Google works. He told to read about the SRE thing, and he got extra 5k that was for a lesser bug. So there were two bugs actually which he didn't know. So $31,000 was for the RC and the 5,000 was for the another bug that was reported. Now coming to the third report of today. So it's a remote code execution on Facebook server. All the big servers, I guess, Google, Facebook, GitHub and all those. So yeah, so what happened was here the reporter scanned the IP range for Facebook that we can see here. So he found a Sentry service that was hosted on this IP with the host name was sentryagreements.facebook.com. So basically Sentry is a log collection web application. It's written in Python and Django framework. So it was running on debug mode. So what debug mode is in Django framework, when you run an application in a debug mode, it like gives out a lot of error message and stack traces and environment variables and all those things. So what happens if it's usually made for developers to test out the deployment before if to debug the instance as the key itself says. So what happened was it was running in a debug mode and then he could see the stack trace, he could see some environment keys, and as we talked in the second episode I guess, so we saw how PHP info was leaking environment variables, although there wasn't anything interesting about that, but we see here it had some interesting things. So there was session cookie name, session serializer and all those things. So one thing to note that Pickle is a binary protocol for serializing Python object structures such as classes and methods in them. So what Pickle does is like if you give a binary object into the HTTP request, so it could be used to unserialize that and structure out in a Python object so that the backend code could consume that. So here he got that session token was binary encoded. So what he could do was he could do a unserialization Python exploit. So but for that he needed a session key. So he found that in the Sentry options key, the environment key, he found that there was system.secret key that was not stepped out. So in the Sentry documentation it is mentioned that it is a secret key used for secret signing. Thus, if this becomes compromised, it is important to regenerate it, as otherwise it is much easier to hijack user sessions. So basically this key was used to sign the user sessions or encrypt the user sessions. So eventually when he got hold of that, he could make his own cookies, and using it could have some embedded remote code execution thing, like it could have some Python code embedded into it, and when the pickle library would unserialize the Python object from the cookie, the code would get executed. So here's a small Python script which he wrote. So his secret key, whatever he retrieved from the server, the logs and the stack trace and the environment that was fetched. So secret key is whatever the environment variable he got there in the Open Center instance. Cookie was the initial cookie, reset cookie. So he sent that to the server and he added a system command, like a Python command, os.system sleep30. So when this cookie was sent after I used the secret key to encrypt the cookie, and when this request was sent with this modified cookie, so the page was taking an additional 30 seconds to load. So this confirmed the presence of the flaw. So this was sent to the Facebook and the system was tracked and patches were put in place. Although it was a critical vulnerability, but only 5,000 bounty was awarded because the server was in a separate VLAN with no user specific data. If it had a specific, if it had user access data, then it would have been a lot more critical than this. Coming to the fourth one, so it's a GitHub desktop RC. So it's from Andre Baptiste, I guess. Andre Baptiste, I think I pronounced that right. Pardon me for that. So he talks about the HackerOne live hacking event that happened in Las Vegas, where the target of the event was GitHub. So he was looking into the GitHub desktop app. So in GitHub desktop app, you have a URI scheme that is x-GitHub client, and this URI scheme is used by the GitHub desktop client. It's an Electron app, and one of the supported actions in this URL is open repo. So if you supply a URL like this, so what it would do is it would open this particular file from this repo. So readme.md. So if you supply the file path readme.md and branch as master, so it would fetch this repo if it's not already fetched. So it would prompt the user to clone it, and then it opens the readme.md file. So you could see where this is going. So you could open any file from any repo, and suppose if that file was a malicious file, so that could be opened. So what he did was, the initial thing he did was he supplied a local file, a calculator app in the OS, in the Mac OS. What he did next was he added a malicious app or malicious code into his own repo, so that he could give the file path of that particular file in his repo, and then that would be executed. So it was a simple Python script that opens a calculator app and then makes a reverse socket connection, and a bin sh is opened on that. So if we see the POC, it's quite a nice one, and the shorter one also. So when you visit the POC file and then you click on the clone button, so it takes some time to clone that. Here he has opened the second server, he got the shell access, the calculator was open, he could list the files, so he got remote code execution on the victim with a single click. So if you notice the bottom left corner, you would see the URI being shown here. Just in a second you would see that. So see, x GitHub client, open repo, GitHub, and that OSX was thing. So that's that about this. Let's move on with the Yahoo vulnerability. So in this, it was a template injection. So templates are basically placeholder text for MVCs usually. So it's not that the data is hard coded or something. So objects are being sent from the backend, and that object is being rendered in the front end template. So it's about RC in a Spring engine. So Spring is a Java MVC. Java MVC basically mean it's a Java framework for websites. So what he found out was, when he was doing a subdomain enumeration on Yahoo, he found that there was a subdomain called datax.yahoo.com. It had a swagger UI.html, but it was displaying a 403 error page. So then he did a directory search using dir search. So he found that adding a space and then passing the file path presented him with a 200, that is a regular HTTP status code, and he got the URI endpoint. So Swagger UI is basically Swagger is a tool to generate API based on a spec. So it displays all the endpoints and how that could be used, like if there's a put parameter, if put request or get request or post, what parameters are required. It's basically kind of a documentation kind of thing. But it's used to generate clients and servers as well, based on just writing the spec. You don't need to write the code as well. So from that he tried to poke some of the API endpoints for vulnerability as an unauthenticated user. So after going through a few endpoints, he found that there was an endpoint here which had the white label error page. It's usually if you're doing a bug bounty thing on Yahoo, you would get this quite frequently. So he found that java.lang, this was some error, and whatever value he inserted, 787, that was being reflected. So the first thing we noticed that whenever something is reflected, you check for XSS. So he tried XSS, however that didn't work. I'm not sure even if there would have been an XSS, the most you could do was you could show a fake page, because it was an unauthenticated user, right? So you won't be able to steal cookies and much. So then he tried this payload. So this is a template injection payload, and that was reflected. So he inserted 191 into 7, and that calculated out to be 1337, and that was reflected. So basically this was being processed. 191 into 7 was being processed. So imagine if this was being processed, you could insert any commands and that would also get like processed, right? So that's what he proceeded with. For proceeding with that, he submitted this part to the Yahoo team. After presenting the Yahoo security team with what he had found so far, they received the confirmation that the template used was the Spring Engine template. And they requested him to see what else he could do, whether he could escalate it or not. So if he ran a payload that could give him the environment variables, and you could see that environment variables are popping up a lot of time, right? So it's usually because people don't hard code the credentials in the credentials or API keys, as we learned in the previous video. So what they do is they add it into their environment variables. As you could see, he has redacted a lot of things, so there would be a lot of sensitive data here. So the first thing you try is to get the environment variables after I've got access on the system. So next thing he did was he tried to execute a command. So here he does cat etc password. So etc password is a file on Linux systems where the users can be listed out. So he did that. Eventually he ended up with doing an id command. So id command basically gives id of the current executing user. Like if I show you here, so id is Asim, CDM and all those things. So id command is basically used to verify if the command execution is there or not. Even cat was enough to do that, but he proceeded with showing this harmless payload as well. So that's good usually. So for this he was awarded a $8,000 bounty. So you might question that if you don't know server side template and you don't know Java, then how you would know to like these commands, how you would get to know. So it's not that all the hackers know all the languages and you need to know everything. So there's a repo, payload all things. It has payloads for almost everything, latex injection or reverse shell injection or a lot of things. Like if we see the server side template injection, and once we figured out that it was a Java, so we could see that these are some of the basic injections. So we saw that he used this to get the environment variables, and then he used the same payload to get the etc password file. So you could see it was this that you could use. So similarly goes for other command like other languages and their execution thing. So it's a nice repo for all these things. You could see there's around 15,000 users who have started this repo. So this is a report from Avinash Jain, which goes by the handle LogicBomb1. So it's a different one than the previous RCs because here he leverages LFI to get an RC. So it's a common strategy that if you get a LFI, you try to go with RC. So what happens, LFI stands for local file inclusion. So he got LFI by, there was a name parameter on one of the endpoints where you could get the local file. So he got etc shadow etc password file to spew out after this. So he entered this file path. So you could see that dot is it basically to go to the previous directory. So etc shadow is in the root directory. So that's why he tried to do that. So to insert as many / forward slash so that it reaches the root parameter and for that. So the name parameter was vulnerable to LFI. So once he figured that out, he tried to fetch the log files of the server. So log files are even important because you could see what files and what other headers are being like written on the log file. So suppose if there is a cookie that's being written in the log file, which isn't usually the case, but if it is being written, so you could easily impersonate anyone else's sessions as well. So he tried to get the log file, but he couldn't get. So he did was he came to know about proc self fd. So fd is basically file descriptor. So file descriptor 1, file descriptor 0, file descriptor 2. So file descriptor 0 is usually for the input, file descriptor 1 is the output, and file descriptor 2 is the std error. So using one of the file descriptors, he got access to the logs, so he could print that. He could like using LFI, he could print the logs. So in the logs, he found that there was a referrer parameter which was getting printed. And since this was a PHP application, what he did was he sent a GET request with a referrer of PHP system ID. So what would happen is when this LFI would get executed and load the access logs, so this PHP code would also get executed, and print the current system ID user that's running the server. So you could see there's Jenkins job, the Jenkins server that was running on this. So this is how you get an RC from an LFI. Coming on to the next, it's quite an interesting bug from Yasho. So it's a Latex to RC. So Latex is basically used to generate PDF files. So on one of the websites, he found that there was a feature called converting Latex codes to PDF. So you like uploaded a Latex doc and it would generate a PDF for that. So he had some like previous knowledge that Latex could be used for that. This is a good article around how you could use to hack a web server using Latex. So basically, Latex has features where you could read input files and include other files from the local system. So what he did in his first exploit was he tried to include the etc password, and when the PDF was generated, the etc password output was like etc password contents were displayed in the PDF. So next thing he did was he tried to execute a command. So he did a id command and he passed the output to a temp file in test.txt. Then he tried to input that, and then in the third command we see that he deletes the text file. So kind of seems like a clean hacker, not leaving any footprints behind. So this resulted in the ID of the current user that was running the code. So UID you could see 33 www-data. So he further moved on to run a curl command, and so that he could exfiltrate data, and on the other end he was running a Python server where this curl command was like pushing data in a base64 format, and he decoded it on the other end. So this was enough to like show the remote code execution. Now coming to the PayPal thing. So manager.paypal.com is a website where this researcher got access, like he could do a RC on that. So while he was doing a hunt on that website, he found an unusual post form parameter called old form data, and that looked like a complex object after base64 decoding. So object, as we saw in the previous bug also, that there was a Python object and there was an unserialization bug that led to remote code execution on the Facebook server. So here he sees that it was a Java deserialization thing. So he knew about YSO serial payload generation tool. So this is the YSO serial payload. So it's used to generate payload that exploit unsafe Java object deserialization. So there are like suitable classes in common collection library that could lead to remote code execution. So this YSO serial payload generator is basically a payload generator for Java objects, where you could do remote code execution based on that. So he downloaded that and he created a simple payload so as to do a curl request on his web server. So he got that on his server. Then he went on to do a cat of etc password, which is a safe enough exploit to show a POC thing. So he uploaded that and he read etc password and he uploaded on his server to get to show the remote code execution POC. Coming to the last bug of today, it's the same researcher, Alfie, as we saw in the first one where he used the Shodan doc, and here again he is using a Shodan doc. So this time he is using Shodan to show Jenkins port 8080, so he's trying to find the Jenkins server. Let's see what he was trying to do. So he found some open Jenkins instances and he tried to install a terminal plugin. So installing a terminal plugin would give him access to the shell on the Jenkins itself. So another thing that you could do was he could have gone to the script console of a Jenkins server, as I showed in one of my write-ups. So you could do that. So you don't need to install a terminal plugin in that case. Nevertheless, he got access and he could do remote code execution. As we could see here, he ran who am I and it showed the Jenkins, and then he did a etc password cat on that. So I hope you enjoyed today's session. There were quite some fancy bugs and good ones. So have a nice day.